will be discussing two numerical related to the energy methods or the relay methods or the equilibrium methods. We will be finding out the natural frequency of a given system. Likewise, in this numerical, we have been given a system. It's a spring mass system. A mass has been attached over here with the help of a spring, and the spring is again attached to a wall or you can say a ceiling like that. So the length of the complete from the mass of the you can say the complete spring is small l, and this is the mass suspended over here. Moreover, one more thing is given, that the density of the spring is given. Density means in terms of the mass per unit length. If you have got this length, this length, this length, you can calculate the mass of it. So we are assuming a length of a element of dy over here out of this spring, who is at a distance of y from the top. This is assumption number 1. Assumption number 2, that we have given a movement in this direction or a displacement so as to have a displacement of x in the downward direction or in the longitudinal direction. Third point, the system is assumed to be under the free vibration. The force vibration is not applicable over here. The free vibration, once you pull the mass downward, after that you keep your hand aside and no more force is applicable to that. After the application, after the removal of your hand or the force, the system starts vibrating and we have to find out the frequency accordingly. So let us see, m is the mass over here, point number 1, m is this mass. Secondly, density of the spring material in terms of the mass per unit length is given. Third point, if I need to calculate the mass of the complete spring, since I know the length of the spring, so length multiplied by density, because density has been in terms of the length per unit mass. So density into length, that gives the ms, m subscript of s, s means the mass of the spring, so as to differentiate it from this mass. That is why I have written a subscript of s over here. Small l is the length of the spring, I have already told you from the diagram. Now consider a small element in the spring. This is a small element whose name is, we have taken as a dy, at a distance of y from the top. Now next point is the velocity of the small element. This, if we need to calculate the velocity of this small element, the small element velocity will be given as y upon l into x dot. Third, next point, the kinetic energy of the element will be equal to half of the mass into velocity ka whole square. So mass of this element will be equal to density multiplied by the length of this element. This is the mass of this element into the velocity. Velocity we have calculated from here. Let the velocity for the complete length is x dot. एक के लिए x dot बटा l और dy के लिए कितना, तो ये वहां से अपन ने कैलकुलेट किया है यूनिटरी मेथड से, जैसे आप लोग बचपन में करते थे. स्मॉल l के लिए आपकी वेलोसिटी है x डॉट, एक के लिए x डॉट बटे स्मॉल l, और dy के लिए स्मॉल एलिमेंट के लिए कितना है, ये y के लिए कितना है, तो ये टॉप के लिए कितना है. यहां से तो ये यहां से इस चीज के लिए आ जाएगा टॉप पे, यहां से यहां तक के लिए आपका x है, तो ये इतने डिस्टेंस के लिए आपका इनटू कैपिटल y से मल्टीप्लाई हो गया. तो ये ओवरऑल आपका ये यहां से वेलोसिटी आ गया. दिस इज द वेलोसिटी ऑफ दिस एलिमेंट फ्रॉम टॉप टू, इसका दूरी जो है y है टॉप से. नाउ वी आर सिंपली पुटिंग द वैल्यू, मास का वैल्यू आपने डेंसिटी मल्टीप्लाइड बाय द लेंथ ऑफ द एलिमेंट रखेंगे तो एलिमेंट का मास आ जाएगा into velocity. So this comes out to be the relationship of the kinetic energy of the element dy. Now total kinetic energy of the spring, because the length of the spring is l, small l, but we have calculated the kinetic energy for an element of dy only. So if I need to calculate it for the complete spring, I will have to integrate it from 0 to l for the complete length. So I am integrating this equation for the complete length from 0 to l. After integration, I get this one. All other things are constant. So x dot is constant, small l is constant, but y is variable. Since y is variable, so you can we will integrate it from 0 to y. So y square becomes y cube divided by 3. If I put the limits, y has been replaced by l cube by 3 minus 0, l cube by 3, the rest of the terms remains same. L square से यहाँ पे L by 3 रह जाएगा. In the next slide number 2 we can view it. In the slide number 2 you can view it. The relationship comes out to be the total kinetic energy x dot by this relationship of the solving from step number 8. This relationship comes, and rho into L again will be replaced by ms. Rho into L will be replaced by ms. L is the length of the spring and ms is the complete mass of the spring. So from rho into L this is ms. 3 ऐसे कैसे, x dot square मेरा ऐसे कैसे, 2 मेरा ऐसे कैसे. So I have made this equation as equation number 1. Now next step, the kinetic energy of the mass. This mass, because this mass has a displacement of x in a longitudinal direction. So the kinetic energy of this mass will be given as half of m into x dot ka whole square. X dot means the velocity of the mass. The equation number 2. Now point number 3, the potential energy of the, because spring has been displaced through a displacement of x. So the potential energy of the spring can be given as half of k into displacement ka whole square. So half of kx square. So this is equation number 3. Now I know the relationship how to find out the total kinetic energy of the system. So the total kinetic energy of the system will be equal to kinetic energy of the mass plus kinetic energy of the spring. So kinetic energy of the mass is over here, half of m x dot ka whole square. So this is the kinetic energy of the mass, and this is the kinetic energy of the half of x dot square and x का square. This is from the equation number 1. ये यहाँ से मैंने उठाया, दोनों को मैंने प्लस कर लिया. Similarly potential energy है, और according to energy method, the total energy of the system remains constant. That means the d by dt of the total kinetic energy plus total potential energy will be equal to 0, because किसी भी चीज का डिफरेंशियल अगर वो कांस्टेंट है तो उसका 0 होगा. So as per energy method, so the total kinetic energy plus total potential energy of the system that remains constant. So since it is constant, if we differentiate it with respect to time, that will be 0, because if something is constant, that is not going to change with time. Differentiating means with respect to time, that is not going to change. So that is why its differentiation will always be 0, means no difference has come from this time to this time. Now we are simply putting the value total kinetic energy of this system, half of this. This is the kinetic energy of the spring, this is the kinetic energy of the mass, this is the potential energy of the spring. This is question number 4. We are differentiating it. We are simply differentiate it and solve it, and 1 to 2 steps you can do it at your own. It's a simple differentiation from equation number 4. Now we are differentiating it and solving it. We will get this relationship x double dot m plus ms by 3 plus kx equal to 0. Again ये पूरी टर्म को मैं नीचे ले आया, x double dot k upon m plus ms by 3 to x equal to 0. So the equation number 5. Equation number 5 can be compared with a fundamental SHM equation, and by comparing it fundamental SHM equation, I can write omega n square, that is a natural circular frequency, that is equal to k by this over here, and omega n equal to equation number 6. Similarly, I can find out the natural frequency of the system. The natural frequency of the system will be given by Fn equal to omega n divided by 2 pi. It means to the natural circular frequency divided by 2 pi. So 1 upon 2 pi, put the value of omega n over here, and we are successful in finding out the value of natural frequency as well as the circular frequency of the given arrangement. Now I will go to the slide number 3, and we will try to solve the another numerical. So what does the other numerical say? We have to add these two harmonic motions. Harmonic motion number 1, where is x1 equal to a sine of omega 1 t, and another harmonic motion is given x2 equal to b sine of omega 1 plus del omega into t. So we have to add this one and find out what is the resultant of this two. If I need to calculate, I have to add x equal to x1 plus x2. That's exactly same I have been asked for to find out. So put the value of x1 over here, put the value of x2 over here, and it. Now after solving it, x equal to, may I write it सेम एज इट a sin of omega 1 t, ये मेरा ऐसे कैसे रहेगा, यहाँ पे मैंने b sin of a plus b का फॉर्मूला मैंने यहाँ पे ओपन किया है। मैं यहाँ पे मेंशन भी कर देता हूं, ओपन द फॉर्मूला ऑफ sin of a plus b। स्टार लगा दिया मैंने यहाँ पे, आपका नोट लगा सकते हैं आप यहाँ पे, so that you may remember it when you will go through it again। So sin of a plus b का मैंने यहाँ पे आपका खोला है, यहाँ पे फॉर्मूला sin a cos b plus cos a sin a cos b plus cos a sin b। So this I have written। Similarly, after solving it, I am rearranging this equation number, step number 2। sin of omega 1 t के क्वेश्चन मैंने ऐसे अलग किया। Similarly, cos of omega 1 t का क्वेश्चन मैंने ऐसे अलग किया। So I kept the name it as number 1। Similarly, I have an equation x small x equal to capital X sin of omega 1 t plus 5। This is again an fundamental equation। So I can again open this equation also, equation number 2। So solving equation number 2, I get capital X जैसे, फिर वही sin a cos b plus cos a sin a plus b का फॉर्मूला मैंने यहाँ पे ओपन कर दिया। अगेन इसके भी क्वेश्चंस मैंने रीअरेंज कर लिए, मैंने और लिखा बीच में, इसके भी क्वेश्चंस मैंने रीअरेंज कर लिए, और रीअरेंज करने के बाद मेरे पास ये आ गया sin of omega t1 के क्वेश्चन ये है। Similarly, cos of omega 1 t के क्वेश्चन मेरे पास ये है, that is equation number 3। So I will compare it equation number 1 and fundamental जो इक्वेशन है मेरे पास एक्सरसाइज का, उन दोनों को मैं कंपेयर कर रहा हूं और उन दोनों के क्वेश्चंस को मैं कंपेयर कर रहा हूं। When I compare it equation 1 and 3 and their questions, I get x cos of 5, x cos of this quotient must be equal to this quotient, and similarly this x sin of 5 must be equal to b sin of omega t। So x cos of 5 equal to a plus b cos of tan omega t। Similarly, the quotient, another quotient is this one। So I have named it as equation number 4 and equation number 5। Now step number 7, if I put equation number 5 upon equation number 4, what do I get? Tan 5। So tan 5 will be equal to this much, and again 5 can be calculated। So I write it over step number 8 as 5 can be calculated। So this is over for today।